welcome to Morse's Math Morsels. Question is, what is a polydivisible number? Well, the word poly, prefix poly, just means many, as in polygon, many sides, for instance. So polydivisible in the sense of whole numbers means that number whose first n digits are evenly divisible by n. And to make that clearer, I'll put up some numeric examples. For example, 12 is polydivisible. The first digit is divisible by 1. In fact, all single digits are divisible by 1, so that's trivial. And the number 12 itself is polydivisible, has 2 digits, and the second digit is a 2, which is even, and that comes out even. It doesn't matter what the quotient is, only that the number is evenly divisible. Or 16, or 38, or 72. These are all 2-digit polydivisible numbers. Divisible by 1 first digit, divisible by 2 in the second digit, the ones place. What about 3-digit polydivisible numbers? Well, we just need to add on one more digit so that each of these examples is divisible by 3. And a number is divisible by 3 if the sum of the digits is 3 or a multiple of 3. Over 1/6, add the digits, we have 7, so we could put on a 2. And that's divisible by 3. The sum of the digits is 9, so that division comes out even. For 38, 3 plus 8 is 11. We can put on a 1. That's divisible by 3. 72, I can put on a 0 there. 720 is divisible by 3, as is 381. So far so good. Erase these and put up some more examples. 5 is polydivisible by itself. 54, so far so good, divisible by 2, divisible by 3, well, we can put in a 6. Add the digits, 5 plus 4 is 6 is 15, and 15 is a multiple of 3, so the whole number is a multiple of 3. Divisibility by 4, number can be divided by 4 evenly if its last 2 digits are a multiple of 4. For example, 64. That's a multiple of 4. So the whole number is also a multiple of 4. Or, I could just as well have used either 2 other digits. 5460, that's a multiple of 4. That's still polydivisible. And one more, which you probably guessed is 5468. Now, as for polydivisibility by 5, simple rule for dividing by 5, the last digit must be a 5 or a 0. So this number is polydivisible all the way up to 5 if it ends with a 0 or with the other required digit 5. And for 6-digit numbers, must be a multiple of 6, so it needs to be a multiple of 3 with the digit sum adding to 3. Or a multiple of 3. But also the last digit must be even, since 6 is an even number. It equals 2 times 3. And put down 6 and extend my little brackets outward. Add these digits, 5, 4, 6, 8, and 5, add up, 10, 18, 28. So I can put a 2 here, make that a multiple of 6. So we have an example of a 6-digit polydivisible number. Only one other digit could fit here. In this instance, 6 more than 2 is 8. So either of these is divisible by 6. Now I'm going to leave this at the 8. Extend this line further, so we're working with a 6-digit number. Oh, how about multiple of 7? No quick and easy, obvious divisibility rule by 7. Just have to try a trial division by 7 and see what sort of remainder we get if you put in, say, a 0. Try that as a candidate, do a division by 7. Let's see, if I work it out, say 180, 40, 42, 35. Oh, that is a little too low. So we erase the 0 and put in a 2 and see if that's divisible by 7. And it is. Well, this is divisible by 7. That's 5,468,582. All the multiples of 7, just add 7 onto this number and make that digit a 9. And if adding on to polydivisible numbers, be careful of carries. You don't want to have to carry over a digit or more. For instance, if I added on 7 again, I'd be changing the 8 to a 9, the 9 to a 6, which would be a multiple of 7, but a 9 in the tens position would mean it's not a multiple of 6 any longer. Same if I added 14 to this number, these last 3 digits would become 603, and 54686 is not a multiple of 5 if I were to keep adding 7s. So can't have the carries over into other digit places. So that's a little introduction to polydivisibility so far. I'm going to do one more example. I'm just going to write down the number 6. Here we go, the nice round number that will have mostly zeros as digits. This is polydivisible, multiple of 2. This is a multiple of 3, 600. Is 6,000 a multiple of 4? Yes. Add on another 0. Is 60,000 a multiple of 5? Yes. And 600,000? Yes, that's obviously a multiple of 6. How about a digit to make it a multiple of 7? Write down mult as multiple. So we'll need to do the trial division rules by 7 and free to do that on your own, and then continue attacking on digits. Try to find multiple of 8, multiple of 9, and 10. All multiples of 10 end in 0, so if you have a 10-digit polydivisible number, that last digit in the ones place can only be a 0. Is there an infinite number of polydivisible numbers? No, the number is finite. There is a largest polydivisible number. It happens to be 26 digits, and no others larger. Alas, because when you get into multiples of 11 and 12, then I'm going to have too many instances of trying to carry over digits when you get into adding 2-digit numbers on. So the carries can disrupt the polydivisibility of the numbers and well into the billions and trillions and so forth. Thanks for viewing.